Welcome to the video about pinhole viewing. We're going to do a project in the following class that incorporates the aperture in your eye, the size of your pupil, and how far away you can distinguish two separate objects. What's going on here is when light passes through your pupil, there is diffraction, which means a bending of the light because of its wave nature and interacting with a small opening. This diffraction causes interference, which limits the amount of resolution that you can see. There's a couple videos here following for you to watch. I wanted to show you a couple here first. So the first video I wanted to show you doesn't change how far from the objects you are, but changes how far apart the two individual objects are. We have here and here these two little point objects, and then you have your eye with its pupil here, and then back on your retina this is what you see, and it's blurry because of diffraction and those two objects, the waves going through your pupil and diffracting, bending because of going through that aperture. And right now you get two separate images. As those two objects are moved closer and closer, notice their images are getting closer until they get so close now you can't distinguish them as two separate objects, and even closer they are one object, even though in reality they're separate objects. Notice our distance from the objects didn't change, but we changed the distance of the objects. If the distance of the objects was between the objects was fixed, we could change whether they appeared as one or two by moving forward and back. That's something we're going to do in the activity. And then here is the same situation, but rather than changing how far apart our two objects are, we're changing the size of our aperture. For us and our eyes, this would be the size of our pupil. And as that gets smaller, notice those diffraction patterns merge until you have just you have just a single source. It appears to you to be one object rather than two in the close, and that is as your pupil gets smaller and smaller. Here is a video for you to determine the resolution of your eye, and then a really neat video explaining how you can use what's called a pinhole to change your vision, and it has some good review information about your eye. So I'll see you in class.
Vision is arguably the most compelling human sense. Words and stories and sounds allow us to imagine strange beasts and far-off worlds, but seeing makes us truly believe they exist. And that's why we place so much effort into correcting the optics of our eyes when they don't work, whether with glasses or contact lenses or surgery. But if you're in a pinch, bleary-eyed, or missing your glasses, there's a simple trick that will allow you to see clearly. Just make a tiny, tiny hole using your fingers, look through it, and the world will become clear again. This works no matter how blurry your vision is. Take off your glasses and give it a try. Amazing, right? But to explain this wizardry, we just need to remember how seeing works. Light travels outwards from a source, bounces off of objects in its path, travels into your eye and onto your retina, where it forms an image. If your eye had no lens, light from a single source would hit your retina in lots of places and result in a smeared out mess, which is exactly what happens when I take the lens off of my camera. A lens focuses that spread out light, corralling it into a crisp image on your retina, and after a little excitation of light-sensitive nerves and interpretation from your brain, you see. But wait, when we look at an object, the background and foreground are usually blurry, because a lens can only focus light coming from one distance away. If an object is too near or too far, its light will again be spread out on your retina, leaving you with a blur. Fortunately, muscles in our eyes allow us to accommodate by squeezing the lens, which changes its focal length so we can see at different distances, except when we can't, or when our lenses become damaged, in which case we need glasses. Unlike a lens, a pinhole or other small opening can focus light coming from any distance. Because it's such a small opening, it only allows light to come through in one place, and thus in only one direction from any particular source, so there's no blur, and everything is in focus. If you're familiar with photography, this is why using smaller and smaller apertures makes everything in your photo come into focus. Of course, small openings like pinholes and camera apertures create crisp images by blocking rather than focusing light, so the images are much darker, which is a major reason why we use lenses rather than pinholes for glasses, telescopes, and eyes. And yet, in a pinch, looking through a tiny hole made with your fingers can help you see. Now do you see why?